students, up to now we have studied two chapters. Okay, now we have to start our third chapter. First chapter law of motion, second chapter work and energy. That two chapters we are already complete. So now today we have to start chapter number 3, which is current electricity. Okay, so in previous standard we have also studied about this current electricity. Okay, electric current. Okay, in that we have seen that electric current now a very important thing in our day-to-day life. Okay, if you observe your home, industries, all offices, banks, all are need electricity. Okay, because all systems are get computerized, and for that we need for electricity to run all that systems. Okay, so this current electricity now becomes very pivotal concept, very important concept for our day-to-day life, and it has various uses, various applications that we are also we have to study in some next standards. But now in this year we have to study what is actually current electricity. Okay, so now first of all, if you see the word current, okay, so if in current what happens, simply the flow of a charges is simply called as a current. Okay, if you see charges, there are two type of charges, one positively charged, second negatively charged. Okay, so among them if you consider the current, okay, so then we have to consider the negative charges, and negative charges are nothing but the electrons. Okay, so simply we can define current as flow of charges or flow of negative charges, that is the electron, is simply called as a electron, is simply called as a current. What? Flow of negatively charged electrons is simply called as a current. Flow of charges per unit time is simply called as a electric current. Okay, so this electric current has various applications that also we have to see. Actually, first of all, this negatively charges electron are simply motion of this negatively charges electron is simply called as a current. So if you see the atomic structure of an element, okay, so this is the suppose nucleus, this is the first cell, only 2 electrons are present in the first cell, then up to 8 electrons are present in the second cell of an atom. Okay, so these electrons are present in the outermost shell of an element is simply called as a what? Valence shell, and these electrons are called as a valence electron. So here generally metals are good conductors of what? Electricity. Okay, their current can easily flow through the metals because of 1 or 2 electrons are present in the outermost shells of metals. Okay, so what happens, these outermost electrons are not very tightly bound to this nucleus. Okay, they are not tightly bound to this nucleus. They can easily move from one atom to the another atom. Okay, these electrons are very loosely bound to the nucleus, so they can very easy make a transition from one atom to the another atom or one shell to the another shell. Okay, so such electrons are called as a free electrons. Okay, so these free electrons are actually what? That also we have to see in later part in this chapter, but these free electrons are play important role. Okay, so this free electron can easily transfer from one atom to another atom, and this flow of negatively charged electrons nothing but this simply what? Electric current. What? Flow of negatively charged electron are simply called as a electric current. Okay, so you have to remember this definition of electric current, that is the flow of charges is simply called as a electric current, and you have to remember this definition. Now one topic we have to see, that is potential and potential difference. Potential and potential difference. Potential and potential difference. Okay. Now for that we have to see one example that we see every day in our life. Okay. So in our home, if you see, the water tanks are always placed at above on the or terrace of our home. Okay. So generally this is the water tank which is placed in our home, and below that our home is here. Okay. So why not we place this water tank on ground? Why we have to place it in the terrace of our home? Simply to increase height of that water from the ground. Okay. So now here for that we have to consider one example of this tank. Okay. So this is one tank, and we have to connect this tank to the another one tank. Okay. Suppose this is another one tank. Okay. So now this tank is full of water. We make even hole here. Okay. So now what happened here? And no water initially present in this second tank. This is tank number 2. This is tank number 1. Okay. Initially it is fulfilled with water and initially it is empty. Okay. So actually what happened here? So as we connect these two tanks to each other. Okay. So what happened here? Here water will be start to flow from this tank to this tank. Okay. So continuously water will transfer from tank number 1 to the tank number 2. Okay. Such a way that transition of water is start from tank number 1 to tank number 2, because we are connect these two tanks to each other by using one pipe here. Okay. So now no doubt about that this water will be transmit from tank number 1 to tank number 2, but this process is start up to how much time? So this is a process, so continuously water level of this tank get decreased. Okay. So such a way that this water level goes on decreasing from the tank number 1, and water level of tank number 2 is goes on increasing. So this process will continues till the both heights of water in both the tank get same. Okay. As height of water in both tank are same, at that time flow of water will stop. Okay. Initially what? This is fulfilled with water and this is empty. As we connect these two tanks with each other by using a one pipe. Okay. So here what happened? This water transmission takes place from tank 1 to tank 2. Okay. And this transition is continuous till height of both the water are get same. As the height of both tank get same, the transmission of water is stopped. Okay. So initially this is a full fill and this is a empty. Okay. This is at higher height, this is at lower height. Okay. So for that we have to, for our convenient to understand, we can say that this is at higher potential or higher potential, this is at lower potential. This is higher potential and this is at lower potential. Okay. So in terms of potential energy, okay, actually that we not have to use your word of potential energy, but still if you see the potential energy, okay, potential energy is depend on height. Okay. Actually I am just telling this type this way to understand you. Okay. So what happened? Heat is at height as suppose this is ground. Okay. this is somewhat height from ground, okay, so it has higher potential energy NGH, okay, and this is zero height, so it has lower potential energy as compared to this tank, okay, so this tank have higher energy, okay, so our convenient we can say that this tank have higher potential as compared to this potential, okay, this tank, okay, this tank has higher potential as compared to this tank number 2, okay, so such a way that water transmission takes place from higher potential towards lower potential, or water transmission takes place here from higher potential to the lower potential, because this tank is at somewhat higher potential, this tank is somewhat lower potential. I told this concept too by using potential energy. Actually this concept is not expressed, or this concept is not described by using potential energy, but I told you for the much faster understanding, okay, so by using that logic we can say that, generally we can say that, okay, so I have to tell you how the water is transmitted from here higher potential to lower potential, because this tank 1 has a higher potential as compared to the tank 2, so here water transmission takes place from higher potential to lower potential. This process is continuous till height of both water get same, both tank get same, means potential of first tank will be equal to potential of the second tank, okay, so when this potential of first tank and potential of second tank get same as that time, at that time what happen, this transmission of water is stops, okay, so we can say that water flow from higher potential to lower potential till both potential get same, okay, that part we are studied by using that our day-to-day life, okay, same way that in case of charges, okay, two type of charges, that is the positively charged and negatively charged, okay, so these positively charged electrons and negatively charged electrons are also flow in an electric conductor. How the transmission of charges takes place, okay, and how the electric current is generated by using this concept we have to study in case of these charges, positive and negatively charged charges, okay. So first of all you have to remember this concept of water. What happen is water is flow from higher potential to lower potential, such a way that electric charges are also flow from somewhat higher potential to lower potential. That's the direction we actually show there, positive to negative of battery, okay, but actually generally electrons are flow from negative terminal to the positive terminal of battery, somewhat lower potential to higher potential. In case of electrons, in case of charges, these electrons are flow from lower potential to higher potential. How the transmission of these charges takes place in an electric conductor, that we will study in tomorrow's lecture. But now for today we have to remember only this thing, that what water flow from higher potential to lower potential, and it will continue the potential of both tanks get same. As the potential of both tanks get same, at that time flow of water is stopped. Such a cases also happen in case of electric charges, okay. How this process is going on, that we have to see in tomorrow's lecture about electric charges, okay. What happens such a way in case of electric charges, how the positive and negative charges are flow in an electric conductor, that we have to see in tomorrow's lecture. For today you have to remember that much part we are studied here, okay. The remaining part we will see in tomorrow's lecture. Thank you.